So what I want to talk about is what we're going to be working on this morning, which is interacting with APIs. In the process, we're going to learn some things about the internet really quickly, and we're going to create a deliverable as well, which is going to start implementing the main kind of skill that we're going to be working on before lunch today. So to get started, we remember HashKitBall from day one, week one, right? And we made this method get players, right? And then we had gamehash.values.map, and then we had like team info, and we could call players, right? And then at the end, we'd flatten that array to make sure that we had like each of our teams. And I remember Dude asked a really good question, which was like, why couldn't we just do something like this? Like, why not just take a game hash home players plus game hash away players, because we know that those are the only two teams in the hash. Why do the work of iterating if we only have two of these things? Why? That's my first question. Why did we decide that iterating might be a good idea instead of simply hard coding in that we're going to have a home team and an away team when we need players? Have it.
Any amount of team players can be fed into an iterator as opposed to just a thing of two teams.
Okay, yeah, that's definitely a strength, right? If we ever had a hash that contained more than two teams, right? Maybe this isn't just one contest we're thinking about, but maybe we have a hash of all of the teams that have played in a given league over the course of a year. Iterating then, yeah, would let us handle more than two teams. But then, I guess still what's the point, right? Because we had that hash hard-coded, right? We had the information on the teams that was there in the Ruby with us, right? And we had that, right? We had the data structure of a hash, and we talked about using the syntax on that hash to get various return values. We wrote methods to do all of that stuff. Then later on, after HashKitBall, we like dove into like classes to figure out ways to organize all of those methods in like reasonable groupings. But all of that like didn't change the fact that we still had just this hash of player information that had to be kind of copy-pasted by somebody else, like a human had to write it down, and it had to be living in the Ruby code when we arrived there. Right, we had to hard code all that stuff. So what's missing, right? What do we not have when we have Ruby? If Ruby gives us methods, return values, data structures, classes to work with data, right? We're missing the data, I think, right? Because the data has to be added in manually. We can do any kind of stuff, right? I'll say here, data. How do we get data? Where does data come from? Pardon? Yeah, from online. I agree. I think that we should go to the net. This is fun. There's like an ASCII text generator you can do. So let's talk about the internet. So we have GET requests, right? A GET request is what happens when you go into a browser and you type in a URL, reddit.com/r/kotor, hit enter, right? That makes a request. We can see the browser thinking, and then it like renders something on a page. This is like a video game I played a lot when I was younger, and then I continued to play as I got older. And that's a whole community around the game, right? So what happened there? I made a GET request. When you type a URL in the browser and hit enter, you're making a specific kind of request. The way the internet works is with a request-response cycle. So your browser is something called a client. It speaks in requests and listens for responses. And when I make a request, it goes over the wires into somebody else's computer, which is there to listen for requests and speak in responses, kind of the other side, the yin to the yang, right? And so I am a client, that other computer is a server, so when I make a GET request, I'm sending along information like a header, hey, here's the URL I'm trying to go to, and hey, it's a GET request, and hey, this is some information about me, the computer that's sending the request, in case the response is gonna change to meet that in some way. I'm also expecting to get back some type of data, maybe some HTML, some CSS, some JavaScript. I could put that up in the header. And then there's like a body of the request, which might reiterate like the URL and where I'm going and stuff. So that's all that stuff gets sent over the wire, right? That's a GET request. A server response is what you see in the browser as a result, right? The server has information, right? And it's been rendered in this browser in some kind of special way. This is because the browser knows how to read HTML, so it knows like when the server sends back an HTML document, how to parse that document and display it reasonably. The browser also knows how to like include CSS stuff with HTML. So if rules about styling, like, oh, this should be green here. Oh, like these words should be a little bit more bold than these words down here. All that stuff can live in a markup file or CSS, a style sheet, right, that comes down, and then the browser is able to parse and read that. So that's part of a server response. Another way to look at a server response is that we could call like .json at the end, and we could see like that there's core information used to populate a Reddit page. And this kind of looks like a hash. There's a whole lot of text here, right? There's an author full name, whether it's saved, whether it's been clicked. We've got a title. Then we've got another post here, another text. This all looks like the sticky stuff at the top of the page, right? And then we get a little further in and we can see like, oh, the title kind of says it all with Jedi Fallen Order. So this looks like one of the Reddit posts, right? So this is all information that's being rendered on the page, but in a nice, friendly, user visible way, right? But the server sent back that core information. So that's what a server response is. The browser makes it look nice. We have a developer console throughout all of this. We have the ability as programmers to hit Command-Option-I on like a MacBook, and I can take a look at like things on the page. I can say inspect, and it'll show me information about the HTML that's on the page. It'll also show me the CSS that's being used to style the HTML. I can do other things too. I can go and look at this network tab, and I can see like anything that comes to the page when I make this request. So I'll hit refresh, and you can see that a whole bunch of things get downloaded, and it'll show you like exactly at which millisecond something started downloading and finished downloading, and what kind of file it was. That's a JavaScript file. This is another JavaScript file, probably a lot of advertising trackers. There's a PNG image. There's a WAF2, which I think is a font that's been downloaded. So you can see all this information about like how your browser has put things together. And as a developer, once we get into later mods, we'll use this tool a whole lot, right? For now, it's enough to be able to tell us that like, oh, I can go in here, and if I wanted to look at a specific ads.js, I could like double click and it'll show me exactly like what code is being run on my page. Cool. So that's a little bit more about the internet. A little more still is this concept of APIs, which is what we're going to mainly dig into this morning and throughout the project this week. So an API just is an application programming interface. That literally just means a thing that you can use. And the interface is like the how to use it, right? Application programming, what we're trying to do. Interface, a way to do it. So basically interface versus implementation, right? The interface is what the user sees and interacts with. The implementation is like under the hood, how is that thing coming together, right? The interface is a magician pulling a rabbit out of a hat, out of nowhere, right? The implementation, you turn around, there's like a mirror, the hat has a secret compartment. Maybe the magician is secretly like 80 rabbits and it's 79 rabbits after the trick is done. Who knows? Magic is fun. But documentation is going to be your best friend, right? To understand how an interface is designed to work, you'll probably want to go to the API's documentation because they'll say, hey, there's a bunch of things that you can do with this. Here's what you can do. And you'll go, can I do this thing that's not in the documentation? And they'll go, here are all the things you can do, right? Because they're not going to say no to you, but the documentation will be very clear on like the limits of how you're supposed to use a tool. JSON, as I just showed up here, is just another data type, right? It is a string formatted as a hash object. JSON exists kind of like what USB does in the physical world. It's a very easy way to pass data back and forth. It's keys and values. When we go over the internet, right, we want to have a universal way that we can send keys and values nested together with like various data types nested inside of them, because whether I'm working in Ruby or whether I'm working in Python or whether I'm working in JavaScript or whether I'm working in Elixir, I'm going to need something that works like an array, right? I'm going to need something that works like a string. I'm going to need something that works like an integer, and JSON can be the go-between. Any of those languages can take a JSON object and turn it into their own home thing, whether you're in Python and it's a dictionary, or whether you're in JavaScript and it's an object, or in our case in Ruby, we'd have a hash, right? And JSON can easily be converted into those things. Yeah, I mean,
when I worked in games, we used JSON for like the bones and stuff for our characters, and I never knew what that was until I did the practice over the weekend.
Nice.
I was like, oh, I understand what they meant by saying JSON all the time.
Very cool. Yeah, it's
a
really
universal data thing.
It's just data, right? It's like this thing has this value, this other thing has this value, and it's a very universal way that we can send back and forth. What we'll talk about in terms of the internet, right, is that an API is going to look like a specific URL, right? That if you visit that specific URL, the API will give you back something resembling JSON. By the way, I have this extension in Chrome called JSON Viewer. I strongly recommend that you find it or something similar because otherwise this doesn't look too great. It's very, very hard to read, but this is nice because I can actually collapse things, which is cool. So I know that I have this object and then data is basically holding everything I care about. And within data, children is holding most of the things I care about, right? So within data, children, we could probably, yep, data seems to be holding, yeah, so basically this gives me a visible way that I can browse through this. And you want to have something like this in the browser because most of the time when you get an object back from an API, it's going to be nested like this. So cool, that's some basic things on the internet. Once we know about what's on the internet, we might find ourselves as Rubyists interested in going out and getting things from the internet, right? If I had a way that I could have Ruby go to this page, right, and give me back this JSON, then I could have a hash. And then I could start experimenting by saying bracket data, bracket children, bracket data, and seeing what kind of stuff is in there, and can I write a method where I can just reuse that hash nesting syntax to get values out that I care about. So that's the task that I want to go through. And so we have Ruby gems that will let us do useful stuff like that. Today we'll work with one gem called REST client, which does the job of sending the GET request. So instead of a browser that's going to render a page, we're going to have Ruby code that sends that URL out, and then when the server responds, we'll have some way to take that response and turn it into a Ruby object we can work with. Because if Ruby already has active record, right, to turn objects into database stuff, and we're trying to make an app where we have interesting data in a database that's served to a user this week, I'd say that most interesting data is real data from the real internet. So we have active record and Ruby kind of sitting in the middle. The database is over here. And we know we've started learning a little bit about how to make that connection, right? But I want to also start making this connection between the internet and where Ruby and active record live. So our goal today is that we're going to use a Ruby gem to access that API. The gems API is basically going to be a method called get. That's the interface that we can use to pass in a URL and talk to a server. And let's go into this app RB and look at some stuff. So first of all, I want to turn these on. I've got REST client, JSON, and pry. These are 3 Ruby gems that I think are going to be useful. REST client's job in this talk and also today, this morning, is going to be to go out to the web and get stuff for you, right? JSON is going to be the tool that we use to take what comes back from the web and to turn that response into something that's meaningful and usable in our Ruby world. And then pry always, so we can debug if we need to. So what I'd like to do is take a look at this API, which is the Google Books API. And there's a lot of documentation on getting a key to this or various steps to authorize yourself with it. But then further on down, it talks about how to work with the volumes in the Google Books API. And they talk about performing a search. And this is the interface that the Google Books API has presented to a developer. The interface is that if you go to this URL at this domain, at this subdomain, right, books v1 volumes, then you can also provide what's called a query string. You see this question mark here in the URL. And I'm not zooming that way, but let me see if I can zoom this way. Sure, that works. So right here, there is a, oops, let me go up. Here's my volume search. Let me go back, sorry. Where did it go? Okay, so working with volumes, down here, this question mark in the URL is basically telling the server that I'm done talking about where I want to go, and now I'm passing in my own keys and values, right? You could think about everything in a URL after the question mark as a hash that you get to define, as the person making the request. So as the person making this request, I've defined that I want to send additional information where the key is Q, and the value equals search plus terms. And this is just a syntax of them showing, hey, if you're going to have multiple words in your search term, you should probably have a plus in between them instead of a space, because URLs don't really deal with spaces very well. So they give an example further down here, where you might say, we'll go to googleapis.com/books/v1/volumes, question mark Q equals flowers plus in author keys and key equals your API key. So this is somebody attaching their own API key to the request at the end, and they're doing an advanced query of flowers within a certain author's name. And so that's going to look for the specific copy of Flowers for Algernon by the author keys. I have a similar chunk over here, right? If we go to HTTPS, googleapis.com, books v1 volumes, and then my query is Ruby plus programming, that's me looking for any book where the title or the content of the book contains the words Ruby programming, right? So what I'd like to do is to have this be a hash that comes back from that request. I'd like to see a list of books about Ruby programming come back, and I'd like to be able to run this app.rb and then see programming books come out on the screen. But to do that, we need to flesh out this method, hash from get request URL. So that's the first thing I'd like to do, and then time permitting, I'd like to see if we can also dig in and like actually start doing stuff with that hash and like iterate through it to make some objects and get some responses. So hash from get request URL, we need to make a get request to the provided URL. That's actually pretty simple, because if we have REST client required, then I think that all we need to do is say REST client dot get and then pass in the URL that we want. And so I'm going to say here response, because I know that when I speak a request, what's going to come back is a response. So when I make a get request, I'm expecting what comes back to be response-like. I'm going to go into a binding.pry right here just to see what we've got. So we'll say Ruby app.rb and cannot load such file, REST client. Oh no, let's try this. Gem install REST client. It might be that this version of Ruby that I'm using didn't have the gem installed yet. That's an important step, right? I need to have the gem code installed on my computer in order for that require statement to work. Ruby is smart enough to know like where all of that version of Ruby's gems are stored. So when you say require, it goes rummaging through the right folders, but we have to put them in the folders first. Cool. So now we're in a binding.pry. Let's actually run restclient.get right here. Restclient.get, capital L every time. So there is a REST client response object that came back, right? If we said .class at the end, we end up, yep, sure enough, it is a REST client response, right? So what did we have? We had a, let's call this, well, we already ran it. We called it response. Let's take a look. Response is this kind of object, and we can see that it starts with like a string, right? And within this string, the first character is a bracket. And then we have this like escaped new line character, and then an escape quote character, and then kind, colon. And I think that what we have here is the start of key value pairs in a hash. But what's happened is it's been turned into a string. This is because when you make requests and responses over the internet, you can only really talk in strings, at least when we're using HTTP. The P in HTTP is protocol. Protocol means rules of communication or rules of engagement, right? The only way to engage with the internet over HTTP is with strings. So what we've got here in this response, I think we can actually say response.body. There's the whole thing. Remember I said the response has a head and a body. Here's the body there. As Alejandro was asking about last week, right, we have this colon at the bottom corner. That means that I'm in this Vim dialog, right? So we can do the up and down scrolling. And I can hit Q to get out of this. But yeah, we had this response.body, and that is exactly the kind of thing that I'd like, right? We have kind, books, volumes, total items, 1619. I think that means it found a bunch of stuff. So that's where this next gem comes in. This first gem has already kind of done its job, right? We've called REST client get URL. We've gotten a response back. It contains behavior that we can call on it, like body, to get the actual stuff that we want. So now we want to actually turn that into a JSON object, right? Well, we want to turn it into Ruby's version of a JSON object, which would be a hash, right? So I could look this up. Let's see, Ruby change string to hash JSON, something like that. Convert JSON to Ruby hash. That's what I want to do. So we have this value. I want to loop through. What do we got? So they mentioned this thing called json.parse, like in this first answer. And I don't know if this is exactly my problem, but I was looking for some kind of syntax. I'll do json.parse Ruby, and I want to pull up the documentation on that. Jump to parse. Parse the JSON document source into a Ruby data structure and return it. So it looks like JSON here is not like just the object type, it's like also the class that knows how to deal with that object type. And so JSON.parse seems like a translator method, right? Parsing in this case meaning like we're gonna go character by character and turn it into the relevant Ruby thing. So in our pry session, let's try it. JSON.parse, and then I'll pass in that response. Check that out. It's an object, right? Let's see. JSON parse response dot class. That's a hash. So if that's the case, you should be able to say JSON.parse response. And what we've covered here is really like the steps of managing an API, right? Did we get to the right URL in the right format to be what we wanted it to be? And when we got a response, did we turn that response into something that we can work with in the kind of code that we have? So if hash from get request is now going to print out programming books, which I think it will, let's get out of here and then come back. We run it. Notice it took a second, right? Because it had to actually go to the internet and make that request. And now it's printing out this gigantic hash. And we can see that it starts with kind, and then it ends with some kind of nested array as the last piece. So going back to this README, if I wanted to get to a couple of these deliverables, the first one would be to take a search term from a user and then use that search term to modify the request. Where in this URL is the search term? Sorry, other tab. Where in here is the search term that we're putting in? It's after the Q, right? The Ruby programming, right? So what I think we might want to do is figure out a way to make this a little more programmatic based on the user input. So what if instead of having all of this stuff, right? What if we moved this string inside? We said something like request URL equals this. Maybe we'll call this the base URL because we'll build on this. And then we'll have we'll take off the Ruby plus programming thing, right? And then we could say here that we have like a term. And that means that the term that I'd be putting in would be just Ruby plus programming, right? So I have these two kind of partial strings now, Q equals and then Ruby plus programming, and I could like join them together. I could say search URL equals base URL plus term. And I think this should work the same way, right? Because we'd have the base URL, which was the first half of the string, and then the last chunk gets added on, and then we do the same exact steps that we did before. I just want to see if that still works. Because if that works, then we can make it, yeah. Let's see, undefined local variable method URL. Oh, I changed my variable, search URL. That's where I want it to go. So that still returns the hash using the same things. So then I think the next step would be to figure out how to take this term, and if it was like Ruby space programming, right? How do we turn the space into a plus? Any idea there? Pardon? Yeah, let's Google it. Pardon? Oh, that's a good idea. Yeah, we could split, right? Because it'll split on spaces by default. And then when we do join, we could pass in plus as the argument. And then when it puts them together, it should do the plus in between. So let's play with this as it is. I'm going to do a binding.pry here and make sure that works. That's a good idea. We're in pry. We have term, which is the space string. If we said term.split, we have this array, and then we say array.join with a plus. Cool. So if we put this all together, it would be term.split.join on plus. Yeah, I like that. Cool. So we could say here that search URL is base URL plus term.split.join plus, right? I could, if this got really complicated, even turn this into a specific single responsibility method, right? We could call this something like def slugify, because what we've really done is turned a name into like a URL slug. Slug is a term that gets used a lot. So we'll say slugify string, and we'll say string.split.join. And so we could say here, slugify term. So term comes in as our search term with a space, goes into slugify with a space, gets modified, comes back out, and it's got the pluses in it. We attach it to the base URL. Everything should still come together the same kind of way. And I really love this too, because there's this like extra element of danger, right? Like I'm going out to the web. Like this is fun because I'm now touching other people's code. Cool, we're here. Let's get out and see if this works. Yeah, go ahead.
Will APIs be more friendly to developers when we do like a search query like we did, and not going to be weird, I don't know, conditional statements to try to get you to type in something strange in order to get the results that you want?
It depends on the documentation and the API that you're looking at. Sometimes it's not as simple as Q. Like a lot of the Google stuff, like they have a similar like syntax around things, and you'll see Q as like a search term used a lot in that API and a lot of others. Another common API that people work with a lot, you can find this bog. I wanted to say dog rolling downhill. Cool. So another place that this plays in, other terms, right? That you just have to kind of know like what you can do with your API. So this is Juju the English Bulldog rolling down the hill. It's a great dog. It's a fantastic dog. I think that the second roll is actually one of the best. And so I might watch my timer here. It's about 16 seconds, really gets a good running start and just goes off, like all the way down to the sidewalk, right? So I have this YouTube watch, V equals, right? So V is definitely the video equals, and then we have this like really short code, which is how YouTube URLs are so short now. But I can do ampersand to add another key value pair to my query string. So I can say ampersand T equals 16. And if I hit enter here, it's going to play the same video, but it's going to start at the time of 16 seconds. So I can just get to the good shit. Boom. None of the preamble, right? Good stuff. And it's that rule too, right? That if you go to like about a third of the way into a video, that's when the video actually starts doing the thing the video is for. And then some mathematician went in and actually figured out that wasn't that far from the truth. There's something approaching a golden ratio. So yeah, based on the API, sometimes you need to have a key in that, and then setting up the key is part of the problem, because they want to know that every request that comes to their API is trackable on their end. They want to associate it with like a programmer's account with like a name and an address and a phone number, so that if it turns out that like someone's using their data maliciously or for unauthorized profit, that they can like track stuff down, right? A lot of times like APIs are more open than that, and like with Google we have a pretty simple syntax to play with. I bet you that like there's a V2 or maybe a V3, who knows like what version of APIs are out there, and maybe in other versions it's not Q, but it's like term, right, as the key. And so some of these might break on other APIs, right? There's no like universal language of API. This is kind of like the Google Books API. So it's kind of like, I don't know, scientists say like there's, you know, people talk about cure for cancer, and then doctors are like, that's silly because there's like lung cancer, there's heart cancer, there's pancreatic cancer, skin cancer. There's so many different kinds that it's impossible to like just say, oh, blanketly we fixed it. It's like that with APIs. There's no like one syntax that's going to get you every resource. You have to understand the shape of each one. What's the interface of this? What are things I can ask it for? What do I expect back? So in terms of making the basic request, we've now been able to get a term in here, and so this could even be a user term now, right? This could be something like gets.chomp, right? We can now ask the user to type in Ruby programming, take that in, and so gets, right, is going to go and get a string, right? And chomp is going to take off the new line character from when the user hit enter. And this is like going back to like command line interface stuff. In additional practice, there are some command line interface labs. So if you want to get a catch up or a refresher on gets.chomp this afternoon or this evening, that's cool too. In any case, I want to run this. I'm going to get rid of this binding.pry because I want to just see what happens. All right, Bulldog. It's going to distract me if I don't get rid of it. Cool. It's sitting here. It's waiting for me to type something, right? I wasn't very helpful. I could have like said puts, please write a search term, but I'll just type Ruby programming, hit enter, and it gives me the same stuff, right? I'm looking at the end of this where it says like learn higher level techniques. This is my control. I know that if my object kind of ends with that, then I've done the same search each time. So now look at what we've done. We've taken our basic get request, which is happening from this tool called REST client, right? We've joined that with a gets.chomp to take user input and use that along with the documented API URL formula to build a different URL for each request. And then we put it all together, send that request through the get, and then finally we use the JSON gem to parse the response, and we have something resembling a Ruby hash. Cool. So I wrote some other code down here that is a little bit more friendly. We have welcome. Welcome to the book searcher. Enter a term. We have a nice predefined method, get user input, that calls that gets.chomp, right? And I have this runner, which when I hit run, it should be able to do the whole kind of kit and caboodle for me. Run will delegate to a bunch of other methods as like my main control center for how I want an app to flow. And you might have a method called run, even run with an exclamation point to say like, very important method, like watch out, there's a lot of stuff happening in here. So I'm gonna call welcome, right? And then we're gonna put this greeting, and then we'll do search term equals get user input, and we'll say P searching for search term. And so if I hit run down here, right? And I get rid of some of my driver code up here. I don't need to P out programming books. I think that this hash from get request is something we could probably use down here, right? We could do hash from get request on search term. And we'll set this to something. We'll say books. And then I'll get into a binding.pry and see what else we can do. So cool, we're gonna run and see what happens. Ruby app.rb. Oh, did I not save? Hang on a second. Rand welcome. Binding.pry. Oops. I don't think it took that last change because I was in a pry. Let's see. Exit. Yeah, there it goes. Hang on. I don't think I'm running. Oh no, I did the thing. Sorry. I'm silly. All right. CD. Chicago. Oh yeah, and let's get this gets.chomp out of it. That line there, right? It needs to evaluate gets.chomp to continue, and I don't really want it to pause and wait for that, so I'm going to just comment that piece out. We'll comment this out because it depends on the variable being set above, and that would break. Cool. If this still runs, we're going to clean up code next. Oh no! Oh yeah, because I just did that. Ruby app.rb. Cool. Welcome to the book searcher. Please enter a term. Ruby programming. Searching for Ruby programming. Now we're in binding.pry, right? So it knows that we're searching for Ruby programming. So search term is Ruby space programming. It's going to be running hash from get request on that search term. Hash from get request is running Slugify, so it's putting the plus in there, attaching it to our base URL. It's made the request via REST client.get, and I think that it might be able to parse this response here. So if we look at books, is it a hash? Cool. If we look at books, oops, books. We got all this cool stuff. Okay. So what is in this hash? We have this total items, right? And this first one says kind books volume, and it's got an ID, and then it's got something called volume info right here. And then it's got a title. So it looks like items within books is an array. So the hash starts out with some metadata, like, oh, it's books, volumes, and there's 1,600 of them. And here's some items of those. And here's the first item, and it's a book volume as its type. and here is some information about this book volume, including a title and who the authors are and what the description of the book is. So I think that here we're finally ready, like now that we've got some data back, to iterate through and figure out how this actually works in terms of giving the user what they want, which, going back to our README deliverables, titles, author names, and description. So the title would be found here in volume info, which is also inside of an item. Okay, so let's say books items, right? You can go one step at a time. Books, items. Nil. Why? Why is items nil when I typed it like that? What's the difference? I'm trying to get to this value, right? This array. And if books is this hash, and I want to get to this key, how did I type the key though? Very good. Yeah, I typed the key as a symbol, but the keys in this are coming back as strings. So I'll say books at string items. And there is the array that I found in the hash above. So we had this hash that opened like this, and then it had a key items which opened on an array. And now when I said books at items, we have just the array. And then we have, it looks like some object in here. It starts with like kind, and then we scroll down a little further. And then we get another object, see the comma here. Then we have another one, kind, ID, volume info. We keep going down, we can see this repeat itself again, right below the comma. Yep, we have kind, ID, volume info again. So we have each item, right, is gonna have this. So if I said books item 0, this could give me like what the first item is. And I could figure out how to get the title out of this. So books item 0 gives me that. Therefore, books items 0, how do I get to title from here? If I'm looking at books item 0 and seeing this, how would I access programming Ruby? Volume info. Notice whoever wrote this code is probably a JavaScript or other language programmer, because they write it with this what we'd call camel case instead of Ruby's snake case. Ours slither on the ground with underscores, and there's hump up and down with capital like letters and things. So volume info, and then what happens within volume info? Title. Look at that, programming Ruby. We could do the same thing for authors, right? We could do the same thing for description. So once we've figured out how to do this for items 0, then we have to like figure out how we could do it for all the items to display like all of the book info. And that's the piece that I think you're going to be most interested in, because that's going to be where you, okay, do I have this information? Can I get access to it piece by piece? Maybe if I have that piece by piece, I can display it to a user. If I have it piece by piece, I can pass in arguments to create an active record object, or I could use those pieces as values in a hash, which gets passed into like an active record object.new or .create, and then we could attach that at the end. So to remind, right, we have the database, active record, internet. We've now gotten from the internet into the Ruby active record space with access to the data that we want. And so everything else is really just glue work to make sure that this is formatted in a way that could live in Ruby objects. So I think that's why they want us to print out this information. So if I use this as like a little guideline, we could say something like books equals hash from get request, and then we could do something like print books info and pass in books as the argument. And here we could have a method called print books info that takes in books hash, and then we could talk about that books hash, right? So we have books hash. Here's how I do this refactoring. If I remember that I have items 0 volume info description, I kind of keep that here, right? And I remember it as a comment. And then I try to blow it out so that it's a multi-step thing. Instead of just saying at 0, then at 1, then at 2. I want to put that into a loop as fast as I can. So I might say here books hash items dot each do item or book. And then I'm left with that syntax kind of hanging in the middle that I had, which was like at 0 is now the book that I'm thinking of, right? And I'm in a loop, so I'm going to be able to do this for each one. So I change this to book, and I have book, volume, info, description. We'll start there. We could also do this with title, right? And authors. So let's do that. And this is a very naive way to print it out at first, but we could always polish this up. I'm mostly concerned with making sure that it's all here. Authors. Cool. So let's try it out. We have this print books info. It's going to try to print books info, and then it's going to hop us into a binding.pry session right after. Actually, I don't think that's going to be necessary because we're going to print stuff. So we'll run it. Welcome to Book Searcher. Please enter a term. We'll try Ruby programming again. Oh, and check it out. Hello Ruby Adventures in Coding, Lindy Lucas, and then a description. Practical Ruby Projects, Christopher Sill, and then a description. If we scroll up, we'll see that same pattern here. Oh, this is interesting though. We have some nils, right, coming back. So the Ultimate Guide to Ruby Programming doesn't have any authors listed, doesn't have a description listed. That's significant to me because what if I was trying to do something about the authors? What if I was trying to iterate through authors, right? Because there's more than one author. I was going to say like authors.each here. We could say p authors of, pass something like this in, right? And we could have a method called authors of, def authors of, and then we could have authors array. We could actually say p print authors. I think that's a better way to do it. Because that's what I'm really doing is I'm taking in an array of authors. And what we'd want to do, right, is like take each name and p it out, right? So we'd say authors dot each do author p author, right? This is like something that I might arrive at before I see the nils. And I just wanted to showcase what's going to happen here, right, is I'm assuming that I have something I can iterate over, but I can't iterate over each one of these things, so I'm going to run into problems. Pardon, Ruby programming. Then we have that right there, ultimate guide, undefined method each for nil class, right? So that at some point we have to deal with this API as being somebody else's code. It's data coming from somewhere else. It's now I'm not in hashkitball land. I can't just go in here and like write that info and say, hey API, I'm going to give you something to fill in. I have to handle it on my end. I have to accept the reality that I'm going to get incomplete data. Some of this stuff is going to have holes, and I need to control for those holes, right? So here in print authors, I could say something like if, right? If we have them. Otherwise, authors could be nil and we'd have a problem, right? But this says like if authors, and I could even do even better. I could say and authors.class double equals array, right? I want to make sure that I have something called authors and that authors is the kind of thing that I'd expect to have and iterate over, right? If I don't have any of those things, then it's just going to skip over printing out anything, and that's what I'd want to happen for like Ultimate Guide to Ruby Programming. If there's nothing to print, I don't want it to say nil, I don't want it to error out, I just want it to be blank. Ruby, let's try another one. Bridge to. Hey, got some bridge to Terabithias. Interesting, we got a nil there. Because it's still peeing out the return value, right? So the return value of a method that has an if condition that doesn't run is still nil. So this method does return nil if there are no authors, right? We could have it return something else. Authors each, right? We could have it, I don't know, we could have it pee out or just return. Let's do it else. Else. We could have it return an empty string. Damn it. Autofill. Come on now. Help. Work with me. And then we'll do, yeah, one of these. Let's try that. Oh, there's our empty string. So we did change the null to an empty string. We managed to change that output value. For description, we might want to have something else, right? This is where like I have to get more nitpicky in terms of like what I'm displaying. I might even have one method that's just devoted to displaying things based on values coming in. I could even set each of these to variables, right? I could say title equals, authors equals this chunk, and then description equals, right? And then I could build a hash where title colon title, authors equals, or author colon authors, description colon description. And then I have the right hash that I could pass into like a book.new or something like that with active record. But once again, we won't concern ourselves with active record yet until we've fully gotten steeped in this internet talking stuff. And that means we have to get good at making these GET requests. Let me move this code down so it's easier to see. Command and Control. Bring it up above the welcome. And so this method here, the hash from GetRequest, is where I think most of the magic happens in our app, right? It contains the URL string that we need to talk to the API. It contains the code that knows how to take a user-provided term and add it to that base string, and then it knows how to use the REST client gem to make sense of the request response and JSON to make even more sense of it for us to use in Ruby. After that, it helped us to go into a binding.pry session so that we could start looking at the object and looking at the keys and starting to say object bracket this key and see, is that the stuff I want, right? And you might not get what you want on the first time you try a key on an object. Sometimes the nesting is going to be deep enough that you have to take a couple of different stabs at it, and that's great because now what you're really doing is you're speaking a hash's language to that hash and letting it teach you about itself, which is like the most badass programming thing possible. Hey, is there documentation on how that hash is set up? It's like, the hash contains its own documentation, mate. Just give me a few minutes with it alone. Just ask a couple of things. And you come away and it's like, oh yeah, it's nested this way and I need to go down here, and then from there I go into here, and that's an array, so that's where I want to iterate, and that's a value, so that's what I want to display. That's the shape of the challenge this morning. I have project groups. These are project groups for today. If you're in a three-headed project group, I think the goal is going to be to make sure that everybody maximizes hands-on keyboard time, which either means you're going to have really, really strict driver-navigator handoffs, or you're going to have some sort of soft agreement of here's when we're going to be a pair in one doing individual work and then checking in with the pair to keep two people typing in a three-person group. Questions on project groupings? If you're doing a solo guided project this week to make sure that you're good on this mod, then you're gonna break off after you're done with the API lab and start on project stuff in the afternoon, like as yourself as your group. That goes for groups 1 and 2. Everybody else will be grouping on projects in the same way. And this afternoon, we're going to be talking more about project setup proper. Jose is also going to talk to you a bit about the blog expectation at Flatiron School and give a time frame for that. Don't worry, spoiler alert, you don't have to do blogs this week unless you are inspired to. But I won't steal his thunder. He'll talk to you a little bit after lunch on that, and then I'll talk right after that on getting started with project things. I think the goal between now and lunchtime is to get into the API lab, which is under the Ruby project section. It's called APIs and Iteration. You'll know you're looking at the right thing because it talks about Star Wars, and your job is going to be able to go to the Star Wars API, get useful information, and do things with it in Ruby. You'll know you're on the right track if you have things in Ruby hash form within 15 minutes and are then spending most of your time working with the Ruby data, right? If you're spending more than 15 minutes to get stuff into the Ruby hash, please let us know. I want to make sure that people have data from the internet on their computers by 11:30 at the very latest today. Cool, cool? Dude. So yeah, I bet you that there are gems that are out there that are concerned primarily with like encoding strings for different kind of URL schemes that know how to turn like, you know, that %20 character or whatever into a space and vice versa. I'm not sure if they're necessary, like if the built-in tool is necessary until I've figured out like to what extent I need to code it. And so in this case, this API exposed to me that I needed to change spaces into pluses. That to me was a small enough problem space that I knew how to solve it with Ruby. If it got more complex or I had more URL transformations to do, by the time I got to the second or third one, maybe the third one, I'd start saying, okay, I'm doing a lot by hand here with URL strings. Maybe I need to find a gem that makes this work easier for me, but I don't want to go looking for that abstraction prematurely because it takes time to research something, it takes time to debug other people's code if it's not working, and generally the less code I have to manage, the better, and from the fewer coders, the better. So I try to keep it in-house until I realize that I have a pattern of needs of that kind of domain, and then I might look for a tool to simplify it. Yeah. I'm not sure what the gem would be, but I do know as a Rubyist that somebody has probably come up with 3 or 4 different versions. And the other nice thing about a gem too is that you can always go on like GitHub and look at the source code of the gem and see like, oh, I'm the person that wrote this gem. Here's how you use it. Like we did with the one last week when we were doing numbers, right? Putting things, yeah, with the database. Cool, cool? I'm gonna stop my video.